So the first chapter was about relations and functions. A lot of this is review from like Algebra 1-ish, like all the way back. All right, Algebra 1, Algebra 2, we've been talking about what is a relation versus what is a function. So my expectation is you can do mapping diagrams. It's just, those are the two rectangles, arrows from one to the other. You should be able to do a vertical line test. Some of these may be combined, like, do a vertical line test, do a mapping diagram, stuff, whatever. Domain and range. Now remember, for domain and range, those are assumed that it's all real numbers unless the function itself has some limitations, okay? So if we look at these, and we'll just zoom in on this section, you'll see that it says all real except, or it has greater than less than. So basically what you're doing is, if it is a rational function like 5 and 6, the only problem that's going to be created is if there is a 0 in the denominator. This is not asking you, is it removable, is it non-removable? This is literally just asking for domain, okay? Meaning, tell me the limitations on your x's, okay? So if it creates a 0 in the denominator, that is a limitation, and you have to list it. Everything except this guy, okay? Now, I do want it in either set or interval notation, so you do need to know how to do both of those depending on what I ask for, or if I say one or the other. So you do have to remember your set notation looks like this, and you'd say x such that, in this case, x does not equal, well, actually, usually they do x is an element of real, x does not equal 3, something like that, okay? That would be set notation. Interval notation, you would say, well, I can have everything from negative infinity to positive infinity except for 3. And so it would look like this, all right? So set notation, interval notation. But finding it is really just finding the limitations. So if it has a rational, like numerator, denominator, if there's a 0 in the denominator, you have a problem. If it has a radical, we are talking about real numbers, not imaginary. So negatives in the radical cause a problem. So that's why this guy has to be greater than 0. That's why this guy has to be greater than or equal to -1. Because anything smaller than that would cause a negative in my radical, okay? And so that's the limitations you're looking for when it asks for domain. So in this chapter, we also talked about specific functions, in this case, linear functions, all right? Slope-intercept form should be second nature to you. So if I am looking at this right here and it says slope-intercept form, then it wants y equals mx plus b, all right? So slope-intercept form should be something you can do like in your sleep at this point in your life. Y equals mx plus b. A couple things. You have to have your slope. You have to have your y-intercept. Slope, that means you have to know how to find slope. So your slope is the subtraction of your y's over the subtraction of your x's, all right? And then you can either take your slope and plug in an xy to find your b, or you can use your point slope, which you're probably familiar with. It comes from your slope formula. So if you know that one, then you kind of know this one. They just multiplied both sides by that denominator to get that equation there. You can plug your points in with your slope, right? Or one of the points, actually, either one. You can choose whichever one you want and solve for y. And then you have it. But you have to find your slope first. You really, that's imperative to have slope-intercept form, okay? If they give you this guy, like this guy, you have your y-intercept, by the way. You don't have to solve for it if they give you 0 and a number, all right? The other thing we did with linear is we graphed them. So find the x and y-intercept and the slope and sketch the graph. Remember, your x-intercept is going to be so if this is, this is in standard form, A, B, and C, right? So your x-intercept is going to be your constant divided by your x coefficient. Your y-intercept is going to be the constant divided by your y-intercept. And then your slope is going to be, you can put it in slope-intercept if you want to, but your slope is always going to be your negative x-intercept over your y-intercept, because you subtract it over and divide to get that y by itself. So if it asks for those three, you just give it to me. And then if it wants you to graph, you can graph a couple ways. You can just plot your two intercepts and connect those points. You already have them. If one of them falls off the graph, then you can plot one of them and walk by your slope to get another point. Either way. But you are just graphing 2 points, connecting the points, and then you have your graph itself. So linear equations, the other thing here is parallel and perpendicular. All right, so they have given you a point. They do want slope intercept. So once again, you are doing y equals mx plus b here. But parallel means they have the same slope. So the only thing you need from this is your slope and your point. And you can do exactly what you did on the page before. Y2 minus y1 equals mx2 minus x1. Okay, so you can use this guy right here. Use your point that they gave you. Use the same slope for that m. And actually, you don't have to do y1, y2, just y. And put it in slope intercept, y equals mx plus b. Perpendicular, remember the difference between that and perpendicular, you do need this guy, but your slope is going to be the negative reciprocal. This is positive 7. Your slope is negative 1 over 7. And then you're going to do the same thing with that point. Again, this should be review at this point, obviously, but review from prior years. The next one is similar to domain, all right, which is why when I say you won't have every single type, you'll likely have something like, what's the domain? Then list the discontinuities and what type of discontinuities. You'll have something more like along those lines. So when it wants to know if it's continuous, continuous means no problems anywhere. But this is specifically saying continuous at a specific point. Is it continuous at this point? If it's continuous everywhere, it's continuous at that point. If it's not continuous, they want you to tell me what type of discontinuity we have. So like 3 causes a problem because if I plug it in, I get a 0 in the denominator. Remember, point discontinuity is if you can remove it, right? It's a hole. So that means if I were to factor this guy, it cancels out. X minus 3x plus 2 is how I would factor that guy up there, which means the x minus 3's cancel, which means it's removable. All right, this one has 2 discontinuities. One is removable, the positive 1, because it cancels with this guy. One is not removable, the negative 4, because it doesn't cancel with anything, so it's point, okay? So you have infinite, point, and then you have jump. And remember, you'll typically see a jump at a piecewise function, right? The pieces where it jumps from one to the next. Piecewise can be continuous, but if they're not, they're typically a jump. Typically you have a jump, unless there's a hole, and sometimes they'll say, use this for everything except this point, use this except for this, and that's point because it pulled out a specific point. So you'll notice the section before gave you a specific point. This just wants to know if it's continuous, and you tell me the points, okay? I will say this is more likely how I'm going to ask. I'm going to say, is this continuous? If not, what type of discontinuity do you have? And then give me the domain and set or interval notation, right? And so I would combine all of these continuous and domain questions into one, like this. And I would say, here's the function. Tell me if it's continuous. If it's not continuous, tell me what type of discontinuities you have, where they occur, and then give me the domain in set or interval notation, right? Because all of those things work off the same thing. What are your x values that cause problems is really what it's asking, right? And so again, you'll see infinite discontinuities, non-removable. You'll see point discontinuities, that's where it just removes at one point. And the one piecewise function is actually a point, but that's because they pulled out one point, right? If they have several functions with different domains, then it will typically be a jump if it's not continuous. But if they just go to one point, then clearly it's point discontinuity because they pulled out 1 point. All right? All right, so we have cubic graphs. We have roots. We have inverses where your x is in the denominator. We have absolute value graphs, right? So you should have, you can go back to your books, you should have all those different types of graphs, and they all move the same. Inside moves you left and right, the opposite of what you think. Outside moves you up and down, the way you think it would, right? Positive up, negative down. And then multiplying by it either squishes it or stretches it, okay? So a small number or fraction will squish it. a larger number like greater than 1 will stretch it, okay? Negatives will flip it, right? So just like when you have an absolute value, the v typically goes up, but here you see this negative in front of it, dropped it upside down, flipped it, okay? So you should know those graphs and be able to sketch them given the graph. I'm not going to make you give me the function with a picture of the graph, but you will have to sketch it, all right? So you will have to sketch it. All right, quadratics, that means degree of 2, right? It also means you're gonna have a parabola, all right? Parabolas will go up or down depending on that negative, just like in the other graphs, okay? Axis of symmetry, that's the guy that is right there in the center that it is symmetric to, hence the term axis of symmetry. If it is in standard form like 35, it's negative b over 2a, something like that, right? Yes?
Yeah.
If it is in vertex form, it's beautiful because they just hand it to you, right? It's just that h right there. So if it's in vertex form, then you have the vertex, which is -1, +3, -1, +3, and you have the axis, which is -1. The only thing you have to solve for here is your y-intercept. Plug a 0 in, solve for y. That's how you always find y-intercept. If it's like this, then you do need to know negative b over 2a gives you this. Plug that guy in to get the y value of your axis. So your axis is going to be negative b over 2a. Your vertex here is going to be negative b over 2a. That's your x value. And then plug it in to find your y value of your vertex. And then your y-intercept is what they just give you. Your y-intercept is always 0c. So standard form is a little bit more workaround, right, than vertex form. Vertex form is simple. This is your h. This is your k. So your axis is just the opposite of your h, remember, because it's, you can think of it as negative h. The formula actually has a minus, so, but just think of it the opposite of what's there. Your vertex is negative hk. And then your y-intercept, you do have to plug it in. So plug it in and figure out what your y value is when you plug in a 0. Okay, so depending on which way you get it, once you have it, you can just sketch it. You know it's going to be a parabola. If you have the axis of symmetry and a y-intercept, mirror your y-intercept over, and you have your parabola. 2 ways of solving here. I did not do completing the square, but we did do factoring and quadratic formula. Honestly, on your exam, I'm probably going to say solve by any method. I'm not going to force you to solve one way or the other. I don't care if you know how to solve a quadratic in life. No one's going to force you at gunpoint to solve it by factoring, right? So the truth is that if you know how to solve a quadratic, you can solve any method you want. You may solve by completing the square. You may solve by factoring. You may solve by quadratic formula. If it is factorable, it will always work. Quadratic formula will always work. The key to quadratic formula is that you have it memorized correctly, right? So factoring means both of these, by the way, factoring and quadratic formula, first of all, has to be equal to 0, always. So if it is not equal to 0, you must set it equal to 0 by moving that constant over, all right? Factoring, factor and then set each factor equal to 0 and solve for x, right? That is what you do if you factor. Quadratic formula, that is, again, must be in standard form, which they all really need to be. Must be equal to 0, just like factoring. And then your x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So once again, on your exam, it's going to say solve the quadratic by any method. But these are the methods that we have learned, all right? All right.
Factoring is so much easier.
So pay attention to what it says. This means addition. Add your like terms. The little dot means multiplication, which, by the way, means FOIL if you have binomials, all right? The open circle means composite, all right, which means take the h, put it into the g, right? So composite is going to be like, instead of x squared, I'm going to write whatever this guy is, 4x quantity squared plus 3, and I'm going to simplify. Okay, so composite. If it has a number, so like these all have variables, okay? These all have variables here. A means your answer is going to be a new function. If it has a number, right, like these, then you need to do the operation and plug in the number, okay? So these answers will be numbers. These will be functions, okay? So make sure you do the same operation, but answer the question completely. Pay attention. It is not going to highlight the fact that one of them has a variable and one of them has a number. You need to pay attention to what it's asking. Finding the inverse. The rules for finding the inverse. You need to switch x and y. Remember, f of x is y, right? So you switch your x and your y, and then you solve for y. And technically, by the way, you replace your y because it is no longer y, it is the inverse with your inverse notation. F to the -1 is your inverse notation there. All right, so switch x and y, solve for y. It's really what you're doing to find the inverse. Now remember, it says state if they are inverses and show y using composition. That's what's down there. Remember, anytime you take a function and you do the composite of that function with its inverse, you get x, okay? No matter which way you do it, all right? So remember, it's your composite. F of your inverse is always going to equal x, or your inverse of your original function. You don't have to actually write the word of your original function is also going to equal x. No matter what order you do it in, you will get x as your answer if they are inverses, okay? So if they are not, like this guy, this says no, it's not an inverse. That's the answer. Because if you take those composites, you will get something other than x. Here, if I take the composite of these two, no matter what direction I do it, I will get x as my answer. So these are inverses, okay? So that's how you're using composition to show if they are inverses. Is to get the radical by itself, right? If the radicals are already by themselves, you go straight to squaring both sides. I want to point out a couple things. First of all, here, if you square both sides, you just get rid of the radicals. We're good to go, all right? Here, if you square both sides, you're squaring that number. You're going to get 81, and then you're going to get whatever's in the radical on the left. On this guy, if you square both sides, you're going to get an x squared, which means you need to go back and use either quadratic formula or factoring to solve, because you now have a quadratic. You have an x squared. So you must factor and solve our quadratic formula and solve, right? Same thing is true down here with these guys. To get the radical by itself, I have to move that over, right? So I end up with a positive x plus 1 equals this radical. I square both sides. I know I say it every time we do this. But what do I have to do to the left side? I FOIL. I will get a trinomial every time I FOIL a binomial, okay? If I square a binomial, rather, I will get a trinomial, okay? So that on the left-hand side is not just x squared plus 1 squared. No, it is x plus 1 times x plus 1. You must FOIL, okay? And then once again, you're going to have a quadratic. You're going to have x squared, which means you need to get everything to one side and either factor or quadratic formula. You must solve the quadratic just like you did earlier. You have to solve the quadratic. All right, which means you might have two answers. However, look at your instructions. It doesn't just say solve. What else does it tell you to do? Check for extraneous solutions, meaning when you solve it, you could get two answers like this, and they could both work like this. Or you could solve it and get two answers, and one of them does not work when you plug it back in. You get a false statement when you plug it back in, which means you end up with only one true answer because one of them was extraneous. It did not work. So pay attention to your instructions. If you need to highlight, check for extraneous solutions, okay? All right, so max turns is something that I really hope you should all get. The max turn is 1 less than the degree, right? Degree is 3, max turns is 2. Real zeros. Real zeros are also called x-intercepts, which means anytime your y is 0. So how do I find that? Well, you could factor, right? Plugging in a 0 gives you your y-intercept. You are trying to find where y is 0, where the function equals 0. All right, so x, real zeros, that is where this whole thing equals 0. You can factor. In this particular one, you can factor, take out an x. And then it's going to be what? X minus 2, x minus 1, right? Which means you have a 0 at 0, 2, and 1. You have 3 zeros, okay? Real zeros. You also have whether it crosses or not. Remember, if it is a repeated 0, it bounces if it repeats an even number of times. So an odd number of times that you have the 0, it crosses through. An even number of times, it bounces, okay? It bounces off of your x axis, okay? End behavior. You know your end behavior by two things, right? You know it by the degree. Even degree, they go the same direction, like this guy over here. Odd degree, they go different directions, like this guy. You also have to look at your leading coefficient. Your leading coefficient tells you if it goes up or down, okay? So leading coefficient is positive, it goes up. If it were negative, they would go down on the ends. Leading coefficient's positive, so it goes up from left to right. If it were negative, it would go down from left to right, okay? So end behavior is your degree and your leading coefficient. Degree and leading coefficient. So sketching the graph then, once you have your intercepts and your zeros and you know what the end does, I'm not going to at this point say you have to know exactly where it turns, but you should know that it crosses, turns, and has to come back down if it's going to cross again. That's just logic. So always put in your intercepts so you know where those are. Then you know your end behavior, and then you're just sketching. You're just sketching at this point. All right, division. You'll notice it doesn't give you a specific type of how to divide. You may divide by long division or synthetic division. Long division is just identical to elementary school. Well, with a few caveats, but identical to elementary school. What does it go into? Multiply and subtract. What does it go into? Multiply and subtract. Your remainder goes over what you're dividing by. That is division, okay? If you choose to do synthetic, remember if there's a leading coefficient, you have to consider that to be factored out of all of your monomials, all of your little pieces, except for your remainder. It doesn't get factored out of the remainder. It's already counted in that, okay? So, no matter which way you do it is fine. I'm not requiring you to do it one way or the other at this point. So if it says divide, just divide. You'll notice on the next page, it does say synthetic substitution. All right, positive, negative, and possible, and then your zeros. One has been given. So positive, remember you're just looking for your sign changes. Remember Descartes' rule of signs? Right? So I'm going to say it goes from positive, positive, no sign change. Positive to negative, there's 1. Negative to negative, no sign change. Negative to positive, that's 2. So that means my real zeros could be 2, or they come in pairs, 0. Okay? 2 or 0. Everybody remember that? To find your negative, you plug in a negative x. So all of your even exponents are going to stay the same. All of your odd exponents are going to change, right? If you plug a negative in and take it to an odd power, it actually changes the sign. And then you count again, and you'll see that you have 2, and again, or 0. Possible. Remember, for possible, you take all of the factors of your last number, every factor, and you put it over all the factors of your first number. So the last number is 18. 1 and 18, 2 and 9, right? 3 and 6, right? All of those. 1, 2, 3, 6, and 9. I think that's all of them. 1, 2, 3, 6, and 9. Okay, and 18. And you put those over 1 or 2, and it's positive or negative, which is where you get all of these possibilities, right? You list all your possibilities based on those. And then it says a 0 has been given. So we know we have 1 0. We can use synthetic division to find another 0. We can use quadratic formula to find another 0. We have listed all of our possibles. So I typically start with positive and negative 1. So like here, they gave me a 0. That means I can divide by that. And then I can find another one by starting with 1 or negative 1. And then it's at that point, you should have a quadratic. So they probably use quadratic formula here, considering the fact they have imaginary answers, right? So once you get to a quadratic, a squared, go back to how we've been solving quadratics the entire time, right? Once you have x squared, you should be able to solve by factoring our quadratic formula to figure out what your zeros are. Write a polynomial of least degree. And they gave you the zeros, remember? They gave you the opposite. So if they gave you a negative 2, then it's going to be if x equaled negative 2, how would I get it? So if x equaled negative 2, that's what it does. Add your 2 over. X plus 2 is your binomial, right? And they say multiplicity of 3. So this guy is just really looks like that. And then you're going to FOIL him to get that guy, right? A couple things I want to point out. If it is a radical or an imaginary, you have to do the conjugate there. So you have to say this is going to be the positive and negative. So x plus square root of 2 is going to be one of them. X minus the square root of 2 is going to be one of them. And then, of course, x plus 1 here is going to be one of them. This is going to have 4, right? So you're going to have x plus your square root of 5, x minus your square root of 5, x plus this little guy here, and x minus that guy. Okay? And so if you have imaginaries or radicals, they come in pairs. Okay? They come in pairs, the positive and negative. And so you have to do both of those. Okay? And I would actually always multiply my conjugates first, because remember, it's going to be a squared minus b squared when you multiply conjugates. So anytime I have conjugates with these, I'm going to multiply those first, and that way it'll simplify it easier. But anytime you have a radical, that's why this one had a degree of 3. It only gave you 2 zeros, but the degree was 3 because one of those zeros paired. It only gave you 2 zeros, but the degree was 4 because both of those zeros paired. All right? Look at the next section. At this point, we have done really all of this over and over. It wants you to identify holes, x and y intercepts, vertical asymptotes, horizontal or slant asymptotes, sketch the graph. The only thing we haven't talked about at this point is your horizontal or slant. Remember, if your degree on the bottom is bigger, your horizontal is going to be y equals 0. So remember, we have our little shortcuts. If my degree on the top is bigger than my degree on the bottom, that's where I'm going to have a slant. I have to do long division. If they are the same, so my degrees are the same, then I'm going to use my coefficients, right? Coefficients. So here I'm going to have to divide, and I'm going to have a slant. If my degree on bottom is bigger, so let's say B is bigger than A here, it's going to be 0, all right? So those are my little shortcuts. 0, if they're the same, use your coefficients. If the one on top is larger, you're going to have a slant, and you do long division, and it gives you your y equals mx plus b is going to be what you do for that long division. That's going to be your slant. In this case, we didn't have a slant. We had a horizontal. Holes, I didn't have any because I don't have anything removable. This -1 ended up being a vertical asymptote because it was not removable. My horizontal was at 2 because it was the same degree and it was my coefficients 2/1. So I have a horizontal. Intercepts, that's when I plug in a 0. So I have a y-intercept at -8. That's why it's down here. X-intercept is what happens when the numerator is 0, as long as it wasn't a whole, right? And so that's why I had an x-intercept at 4, because if I were to set this equal to 0, add 8, divide by 2, I would get 4. And so that's where my x-intercept came from. And then I'm going to sketch it. Sketching the graph, you already know this guy's going to be down here, right? Because you already had a y-intercept and an x-intercept that threw him down here. We know this is up here because I do not have another x-intercept. Had it been below that horizontal, I would have had to cross the x-axis again. And I know I don't because I only have one x-intercept. So you can assume that you can sketch it up here because down here would have crossed the x again. And I cannot cross the x. I only have one intercept. So you're going to use all of the skills at this point that we've talked about, discontinuity and everything else, to get to this point. So solve the equation, check for extraneous. You literally just have to multiply everything by the denominator, right? By the common denominator. So like for this one, my common denominator is x squared. If I multiply every single piece by x squared, I will get rid of my denominators. And then I just have a basic equation. If it's more difficult, this common denominator is this b squared minus 5b. But if I multiply everything by that, I'm going to get rid of all my denominators. And then I'm going to solve. This doesn't mean that it's going to be basic solving with just an x to the first power. You may have to use quadratic formula. You may have to use factoring if it's a quadratic. But you are simply finding your common denominator here. Find your common denominator. And then multiply everything by it. Everything, every piece of it by that common denominator, and then just solve. All right, so anytime you have a fraction, that's actually how you can do fractions, right? Get rid of your denominators by multiplying everything by the common denominator. That is chapter 2. So rewriting from log to exponent or exponent to log, bases stay the same. Exponents, depending on what you're solving for. Logs are solving for exponents. Exponentials are solving for the answer taken to the exponent. So just make sure you rewrite them correctly. All right. Then we used logarithms. So we rewrote it and solved. We're basically saying 2 to what power equals 32. 3 to what power equals 243. Remember, if it's in a denominator, your answer is going to be a negative exponent. If it gets smaller, which I don't think any of these two, it's going to be a fractional. So what power do I have to take 4 to get 2 is going to be 1/2, right? Because it's went from a larger number to a smaller number. So anytime your base is bigger than the number you're solving for, it's going to be a fraction. Anytime your base is to a fraction, then it's going to be a negative exponent. Expanding and condensing. Once again, this should be pretty second nature. Remember, when you have a log of two numbers multiplied, those expand by addition, and they condense the other way, right? They have to have the same base. If it is division, they expand by subtraction. And if it is to a power, you can put it in front as an exponent. So if I have something to a power, that guy can expand to be in front. All right, so those are my 3, expansion and condensing. Remember, they work both directions. Couple things to keep in mind. These radicals, those are going to be fractions. So this is the same thing as multiplying by 1/3, which is fine. You can leave it as 1/3. Typically, though, it will give it to you like this if you're condensing. So just keep in mind that is a cubed root. That's why that condenses to a cubed root, because it's like a 1/3 in front. Anything to a fractional power is a radical. All right, so just keep that in mind when you see it this way if you're condensing. And you're going to use condensing for solving too. So solving equations here with my fixed rates as well as my continuous. So remember, you have your principal times 1 plus your rate over the number of times to the number of times your number of years, right? So when you're doing that equation, you may need to use logarithms to solve, but your account balance is going to be your principal, 1 plus your rate over the number of times. You combine a year raised to the power number of times per year. Continuous is the one everybody always remembers, right? Is that guy right there. Natural number E to the rate times number of years. All right. These will not be separated necessarily on your test, meaning I could give you one where you plug it in and solve, or I could give you one where you have to use logarithms to back into the exponent, right? So just remember to look and see what you're solving for. If you're solving for your account balance or your principal, you're not going to have to use logarithms because you've been given everything. But if you're solving for your rate or your time, you're going to have to use a log to solve back into it, right? And that's the whole point of this particular chapter is logarithms, all right? Because you have to get a log out of the exponent, which is what you're doing here, basically. Solving these guys, remember when you're solving logarithms, you have to have the log by itself, which also means you have to condense if you have multiple logs, okay? You cannot get rid of a log when there's multiple logs being added. So you do need to condense. Like this guy, you would have to condense using your method of condensing. This is being added, so you'd have to condense by multiplication. And then you could get rid of log by your bases. These particular bases are base 10, so, and they're a log on both sides. That's beautiful. They just go away. Your insides equal each other. If it's like this, get the log by itself, meaning add that 3 over. Well, then it's to a power, so it's to the 1. But get that log over and then raise both sides with a base 4. Your base 4 gets rid of your log 4. Over here, it's 4 to whatever power you have, okay? So make sure you're paying attention to how we're solving these. Get the log by itself, subtract your 6, divide by 8, and then take both powers with a base of 4. The 4 on this side is going to get rid of the log. Over here, you're going to have, 4 to the second power, I think. So you're going to have 16 on this side. And then you're just going to solve a plus 5 equals 16, right? A equals 11. So you're using all that stuff before to get rid of it, all right? But you do have to get this guy by itself. You do have to get it by itself before you do anything at all with that log. I think that's the number one problem we had on our test, that we have to have only one log, and then we can get rid of it with our base. That cancels. A plus 5 equals 4 squared. That's 16. That's how we get A equals 11. All right? So you do have to condense and get logs by itself before you can get rid of the log. You cannot say, oh, log, we're going to raise everything to the 10th power here. You can't do that. You're going to get the wrong answer. You cannot raise everything when you have multiple logs. Get condensed first and then do it. Conceptually the same thing. It's just that what you're looking for is in the exponent. Again, get your bases by itself. Like here, I'm going to divide by -2, right? And then I can do the log of both sides and I can expand. So like if I were to do this one, I'm going to subtract that 10 first. I have 3 to the 6x equals 57. You can do log of both sides, or you can do change of base. It doesn't matter. Log of 3 to the 6x, I can now use my expansion. I can pull that 6x in front. 6x times log 3 equals log 57. I can divide both sides by that 6 log 3, and I will solve for my x, right? On this side, my 6 and my log 3 cancel. I get x, and I plug this in. Log 57 divided by 6 times log 3. All right, and I will get my answer. Your logarithms are, they say rounded to the nearest hundredth. It's usually actually to the 10 thousandths is what it's probably going to say on your test, by the way. It's usually 4 decimal places, so read your directions. Make sure you don't get rounding errors. So if I were to look at these problems here, the only difference is I'm using the same equations, but likely at this point I'm using logs to solve, all right? And like I said, on your exam, you probably won't have both. Your basic investment was just a stepping stone to get to the logarithm. So on your exam, you're likely going to have it where you have to solve using a log, not just plugging it in, all right? Plugging it in is like an algebra 2-ish type question, okay? These are the last 2 chapters that we did. Remember, when you're converting, you're either going to multiply by your 60 and your 60 again, or you're going to divide by 60 and 3600, okay? So depending on what you're doing, you're converting. So don't forget that you need to multiply and then take the decimal and multiply again. So when you multiply once, you're going to get the 15, but then you're going to have another decimal that you need to multiply again by 60 to get your seconds. Here you're going to divide, right? So you have to, or you're going to have to take the 41 and divide, take the 51, right, once you get it, and divide by 3600. So make sure you divide, and then here you're adding your decimals up to get your total decimals, all right? You should know how to convert from one to the other. From radians to degrees, you're going to multiply by 180 over pi to get rid of the pi. For degrees to radians, you're going to multiply by pi over 180. So you should just be able to convert back and forth between radians and degrees. All right. Length of the arc. There's a couple ways to do length of the arc. But remember, you're really just a percentage of your circle. So the easiest way to remember the arc formula is to think, and your sector. All right, so arc is literally a piece of the circumference. Arc is a piece of the circumference. And so if I have a piece of the circumference, I really want to know what piece of the circumference. So you want it in radians, but it will naturally change to radians if you do it. So if you have your degree measure, so your degree measure over the total measure of a circle, and then just multiply by your circumference, 2 pi r. All right. If you're talking about a sector, which is like a piece of pie, right? Then it's the same thing. What percentage of the circle do I have? And that's pi r squared. That is the area of a circle, right? And so you can just do your percentages if you want to. Everyone's favorite actually is SOHCAHTOA. Right angle trigonometry is something, again, that should be second nature. Depending on what it's asking for, don't forget that you're actually answering a question. All right, so I'm not looking for an angle measurement if I'm saying what is the secant of an angle. Okay, so you're going to use SOHCAHTOA here, right? And then these are asking for the actual trig answer, which means I want exact, so I want fractions here. You need to rationalize a denominator if it has a radical. A couple things, I mean, just basic stuff. But these are basically just asking for the fractions, all right? If it wants the angle, it's going to look like this. Find the measure of the angle. There we go. We're still using SOHCAHTOA. You're still going to set it up with opposite, adjacent, and hypotenuse to figure out which one to use. But remember, these will use your inverse in your calculator. Anytime you are solving for an angle, you are doing the inverse function, right? The inverse function in your calculators. The first section, you don't need your trig functions on your calculator for the first section. You just need addition and subtraction, Pythagorean theorem potentially, okay? For this section, you do need your trig functions on your calculator, all right? You also need it for the next section. Again, you're using SOHCAHTOA, but now you're trying to find a side length. Okay, so figure out what side length you're missing. Are you missing opposite, adjacent, or hypotenuse? Use the correct SOHCAHTOA trig function. And now you're not using inverse because you have the angle. You're going to say the sine of my angle equals my opposite side over my hypotenuse, depending on what you have. Like for this one, this is my opposite, this is my hypotenuse. I will plug in my 15.1 degrees. I will plug in my x, that's what I'm solving for. I will plug in my 16, that's my hypotenuse, and then I will solve for my missing variable. You're still using SOHCAHTOA at this point. Nothing crazy. If you have word problems that go along in this section, whether it's this one or the chapter 5, you're just going to need to draw, what's going on. I have some type of right angle in this section that's being drawn probably, right? In my law of sines, law of cosines, it won't be a right angle, okay? So pay attention to the wording, all right? If they say a pole standing on the ground, you can assume it is perpendicular to the ground. Diagonally to the ground, that's your hypotenuse. So just look at key words that they're giving you when you do these word problems. If it's going to be a law of sines or a law of cosines, you're going to notice angle measures that are not 90 degrees, or they're going to give you all the side lengths. All the side lengths, and you can immediately tell if side lengths are a right triangle by the Pythagorean theorem, okay? So if they give you side lengths and it's not a right triangle, you're going to jump to law of cosines, right? You're not going to be doing basic SOHCAHTOA if it gives you something like that. All right. At this point, we did move into any point. This is where remember, not SOHCAHTOA so much anymore, but your sine is y over your radius, your cosine is x over your radius, and your tangent is your y over x. Radius is just Pythagorean theorem, okay? Radius is just x squared plus y squared equals r squared, okay? So they've given you your x, they've given you your y. You have to solve for your r, and then you're basically creating a right triangle on the unit circle. You do have to pay attention to your positives and negatives. Your r will always be positive, clearly, because it is the distance formula. But your x and y may be negative, which would affect your sine, cosine, and tangent, positive, negative. This is asking for a specific one. All right, so you may need to solve for r. You may not. If it asks for cotangent or tangent, you don't have to solve for r. It gave you x and y, okay? But if it asks for one of your other 4, you're going to have to solve for r and then answer the question. I am asking for a fraction here. I'm asking for a trig answer. All right. And once again, you don't have to use your trig functions. You're literally just adding and subtracting here. All right. So when it asks for reference angle, it's the distance to the nearest x-axis, which in this case, the reference angle is 45 degrees. And then you actually have to answer the question. Then what is the cosine of that angle? Well, the cosine of any 45 is square root of 2 over 2, but I am in the second quadrant, which is why that is negative. All right, so you're literally just giving me my reference angle, nearest x-axis angle, and then giving me my sine, cosine, tangent, whatever, with the correct positive, negative, depending on what quadrant you're in. Graphing. I think by the time we got done with this, y'all got a handle on graphing. All right. My amplitude, that is the number in front of my trig function. So I'm going to say absolute value of a here, right? My period, that's going to be using this 1/3. So we're going to say pi over my b there, right? My b is 1/3, the number in front of that. So 2 pi over 1/3 gives me my 6 pi. Phase shift, this is going to be the opposite of my C over my B, all right? Remember, inside, if it's positive, it moves you left. Inside, if it's negative, it moves you right. That's why negating it helps you see if you're moving left or right, negating the C over the B. Vertical shift is always my D. That's the guy on the outside. All right, I do have to know my points for my sine and my points for my cosine. Remember, sine starts at the initial, whether it's the phase shift, it typically starts at origin without the phase shift. 1/4, it's at the top, amplitude, halfway through, back at 0, or your vertical shift. 3/4 of the way at your lowest point away from amplitude, and it ends back at your midline, okay? And then cosine just shifts over from that. Cosine starts at your highest, goes to your midline, goes down to your lowest, back to your midline, and back to your highest. So just know your points, your quarter points for those two, and then move it accordingly. Also. All right, chapter 5. Chapter 5 introduced my identities, Pythagorean identities should be second nature. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. Cotangent squared plus 1 equals cosecant squared, right? So we should know those when we are sleeping, right? When it says something like this, pay attention to the fact that it gave you a quadrant, all right? So it's giving you all the information you need. It's giving you one of your features, one of your functions. It's telling you what quadrant you're in based on that. I know my cotangent is negative and my sine is positive. Cotangent's negative in second and fourth. Sine is positive in sine is negative. Sine is negative in third and fourth. So this just told me I'm in my fourth quadrant, okay? Use what you have. It gave you cotangent, it wants tangent. Flip it, right? It wants secant. Well, once you have tangent, use Pythagorean identity and find secant, okay? So you may all solve these differently. I don't know because there are different ways to solve them, but use your identities to solve. You need to know your identities, all right? That theme goes along here too. Again, it's not letting me simplify this, so you're going to end up with something besides that. You can just do this and say, nope, we don't want that side. We're not going to get that side if it wants me to do this on a test. So it's going to look like this, which means you're not going to get that. You're actually going to end up with this cosecant squared. All right, simplify the identity. This one's really easy because it is an identity, cotangent squared plus 1. But simplify means you're going to rewrite it some way so that you get nothing as a fraction. Like for this one, you should be able to do this guy without that piece of it. But rewrite it. Your cotangent is going to flip, so that's the inverse of cotangent's tangent. Your secant squared, the inverse of that is cosine squared. Simplify and rewrite it, okay? So these are just using your quotient identities, your Pythagorean identities, something like that to simplify. The next page is verify, which means you are going to have both sides. They're going to be more difficult, but you can work both sides if you need to. All right, so you can simplify one side and simplify the other and see if you get it to the same thing, or you can choose the easier side to leave alone and try to simplify the more difficult one. All right, whatever method you want here to simplify these. Your answer key actually does tell you the step-by-step process that they did, but that doesn't mean it's the only way you could simplify this to verify it. Okay, but it does give you one way. Solving equations. Solving equations are going to look like this, where you just use your Pythagorean identities, or it could include half angle and double angle identities, okay? I will say on your exam, it probably will not be split up like this. If you have trig solving, it's all going to be one spot, whether it uses Pythagorean, half, or double angle. They're not going to be split like they are here or on your test. But it will all be from 0 to 2 pi. I'm not going to make you give me the common one with the plus or minus, 2 pi. So you will be solving for one complete circle. Give me every angle that fits it. Couple things to keep in mind when you take a square root, it's the positive and negative root, okay? Get your trigs functions all on one side and factor. That's usually how you're going to do that, all right? Don't forget basic factoring. If you need to rewrite it as an x until the very end so you can remember how to factor, that's fine. But you're just solving these equations and then telling me what angle gives me the answer. These are exact values, so they are asking you to plug in double angle or half angle, depending on what it's asking for. So pay attention to what quadrant you're in. That will affect your positives and negatives. Pay attention to what quadrant your theta is in if you use half angle, okay? So half angle, you may use one quadrant to solve, but your final answer is actually in a different quadrant because it's the half angle that you're solving for, okay? So just pay attention to what quadrant you're in with these. All right, when you do these, and positives and negatives, and pay attention to your radicals. Don't forget to rationalize your denominators. All right, so if you have a huge thing under the radical, like in your half angles, make sure you simplify that denominator out. It doesn't need to stay in there. And you may have something like this where you have a radical inside a radical. That's okay. Law of sines, law of cosines. You do need to know your law of sines, law of cosines. So make sure you remember those. These can be flipped depending on what you're solving for. All right. And again, for a law of cosines, it's just the sides that you have. So it's not always A, B, and C. But the one on the outside and the cosine should match depending on whatever side. And remember, it's just talking about opposite sides. So if you have an angle The same side length with the lowercase is just the opposite side to that angle is how it's set up. So you may need to sketch it. If it gives you something like this, you may need to sketch. But remember, your answer is I need every angle measure and every side measure if it says solve the angle. That's what it's asking for. Every angle measure, every side measure. We also did area. And again, it depends on what you have. You could say 1/2 AB sine of C if you have an angle on the sides that make up that angle. If you don't, you may have to use Heron's formula, which is your semi-perimeter. That's just half of your perimeter. And then subtracting those side lengths from there. All right, so it just depends on what it's given you. If you have all side lengths, you're likely going to use Heron's formula. If you have an angle, you could potentially use law of sines to get the angle you need or the side you need, and you could use your 1/2, all right? But one of those two formulas, depending on what they've given you, is what you're going to solve for. If you are looking at word problems, and all of your trig word problems will likely be together, meaning your SOHCAHTOA word problems and your law of sines, law of cosines. It's not like I'm going to separate your trig word problems, okay? So pay attention. If it is perpendicular to the ground, that is a right triangle. You're going to use SOHCAHTOA. If they've given you different angle measures that are not right triangle angle measures, you're going to use law of sines, law of cosines, okay? Or if they've given you 3 side lengths that don't make a right triangle, law of sines, law of cosines, okay? And so just pay attention to the wording of your word problems. If it's given you a basic perpendicular, a building standing there, how tall is the building, how tall is the tree, that's a right angle trigonometry, okay? You can assume the tree's not leaning. But if it gives you something where it says this guy is this distance from here, which is this distance from here, which is this distance from here, we're probably not in a right angled situation, okay? So pay attention to these word problems. You're going to use either SOHCAHTOA or your law of sines, law of cosines for your trig ones, right?